Hi everybody, it's Mrs. Peachy from your WCA Physical Science class, and today I'm going to be doing a lab tutorial for you for your portfolio. It is Unit 4, Lesson 5, Building Electrical Circuits. So we're going to look a bit about circuits, current, and Ohm's law. We're going to take into consideration voltage as well as the resistance in these circuits. And you're going to be using a sim that is found in the lab in order to complete this portfolio. Should be pretty simple. So if I kind of move through here, you're going to see some information that comes up on different types of circuits. And if you look at what it says here, it says click on the link below to complete the circuits gizmo to practice the concepts from today's lessons. The exploration guide found within the simulation will help you work through the gizmo. Click on the lesson materials link, which appears on the top left corner of the screen. Once you enter the simulation to access the student exploration sheet, you do not have to complete activity A. Okay, so let's go ahead and click on here. This is what I'm going to have you turn in to me, by the way. So I don't want that student exploration sheet turned in. I want this sheet turned in. And this is a PDF that you'll find, linked to your lesson. As I've said all year, ladies and gents, I want you to right-click on this, save as, put a title that you will remember, save it to the desktop of your computer. Okay, I can go here and I can save this to the desktop of my computer. Let's see. Here we go. And I can save this as my, circuits lab. Okay. Then I can actually close this out. This particular window, I can go to my desktop and I can find my circuits lab on here, open it, and it will open in, hopefully, in Adobe Acrobat. Here we go. And then this is where I'm going to want to make all of my edits, adding into the boxes, and then making sure that I save this again at the very end so that I can attach it to your Dropbox. That's what you're going to want to do here, okay? So going back to this unit, it next asks you to go to the lab. So we're going to do that. Oops, I apologize. Right, that's the top link here. And that's going to bring up the circuits gizmo. And you are going to want to grab the student exploration sheet out of here, because this is going to give you the questions that you're going to have to answer and put in the guide that you need to turn in to me, okay? So we're only doing activities B and activity C. So you're basically going to be observing the difference between a series circuit and a circuit in parallel. And you're going to be rigging up a circuit by choosing multiple or having multiple paths and stuff available to you. It talks about something called Ohm's law. And Ohm's law is V equals I times R, right? And if you remember, what those equations stand for, V equals I times R. V is voltage, I is current, which is measured in amps, and R is resistance, which is measured in ohms. So that's how we're going to determine anything. And like I try to say to you guys sometimes, one of the best tools that you can use is the magic triangle. If you're not very good with algebra, like here, you can use this magic triangle. V is equal to I times R. I is equal to V over R, and R is equal to V divided by I. So it allows you to solve for any one of those three variables simply by covering up the variable that you want to solve for and then following what the triangle tells you to do. If you have to move across, you're multiplying. If you have to move up and down, you're dividing, okay? So that's Ohm's law. It's basically telling us that, voltage is inversely proportional to resistance and to current, right? So that makes sense. All right, so let's go back and look at the lab itself again. So you're going to be building some circuits here. You've got all the different tools that you need to build the circuits. You have wire, you have light bulbs, batteries, you have different resistors that have different measurements, 10 ohm, 20 ohm, 100 ohm, and 200 ohm resistors. You have different fuses, and a fuse would basically, if you exceed the amperage in the circuit, it's going to blow basically the, kind of burn it out for you so that you don't end up with a fire. They're pretty important. And you have some measuring devices. You've got a voltmeter, an ammeter, and an ohm meter. Okay? Okay, so let's look at the student information sheet and kind of see what it tells us to do here, okay? So we're going to skip activity A, but we're going to move on to activity B. And activity B says, in a series circuit, there's only one path for charge to flow. What are the properties of series circuits? Number one is observe. Turn the light switch on and observe the light bulb. Then start replacing the wire segments with new light bulbs. So basically what you're going to do is you're going to create a circuit as is shown in this picture. And if you can see this, it's just wires with a single battery, a switch, and a bulb. So this should be pretty simple for you guys to be able to do, because essentially all you're doing is kind of following the picture and answering the questions that goes along with it. Okay, when you get to some mathematics here on the second page, you're going to have to calculate things like current. In a circuit here, in a parallel circuit, current is the sum of the current of every branch, right? And again, you can rewrite this because current is also equal to voltage divided by resistance. So we can do this. And then it shows us that, that in this case we can actually simplify this because the voltage is the same for each one. So those ratios are all going to be the same. And so that's where we get the equation that the resistance is equal to, well, 1 over the total resistance is equal to 1 over each of the individual resistances. So you'll have to do some mathematics to solve the questions in practice set 8. So before we continue with this tutorial, I want to show you a little bit about what a series and a parallel circuit actually are. Okay, so we're going to talk a little bit about difference between series and parallel circuits. And as you probably already know, that a series circuit has just a single path for the electricity to follow, whereas a parallel circuit has multiple paths that electricity can follow. And remember that electricity is just the flow of electrons. So electrons are flowing from one place to the other. And they do this because of voltage. Voltage is essentially the difference in energy across the circuit itself. Okay? So if I have a battery, for example, this is supposed to be the minus side, so I'll do it like that. So this is my positive side and this is my negative side, right? So if I have a battery like this, there's going to be a potential difference from the positive side to the negative side. Think of it like a hill. This is the positive and this is the negative, okay? And we know that stuff will flow from positive to negative, or that's going to flow downhill. If that hill is very shallow, the slope isn't very steep, it's not going to flow as fast. If that hill is very steep, the flow will be faster. So depending on the difference in energy between the positive and the negative poles of the battery, the faster that flow is going to be. So there's going to be a relationship between voltage and the flow of electrons here, which is the current. So when we make a circuit, we just take a wire and we connect the positive end to the negative end. Now this is what we would call a short circuit because there's nothing to stop the electrons to flow from one end to the other very, very quickly, and eventually that wire will get very hot and might even start a fire, so we don't want to do that. So we can add things to this. We can add a light bulb. Right? So this light bulb adds resistance to this circuit, and we can add a switch, say. And that switch, when it is in the open position, will stop the electricity from flowing, and when it is in the closed position, it will allow electricity to continue to flow. Now, another thing we can do in this particular circuit is we can add more than one light bulb. I can add multiple light bulbs if I want. Now what's true about this now is that each of those light bulbs is going to slow down the flow of electrons. I like to think about these as toll booths. Say you're in a highway and you have to stop at a toll booth. So you've got to stop here. You're going to slow down. It's going to slow everybody down behind you. Then you're going to speed up a little bit, but you're going to stop here again. And again, everybody else has to back up behind you. And you're going to stop here again as well. So you're definitely going to slow down because of the multiple resistors. So if I increase the resistance in a series circuit, then I will decrease the current. Okay, so that's true. Now let's look at Ohm's law. V equals I times R, right? For V to remain constant, the voltage, if we don't alter the voltage, but I increase R, the only way to keep this the same is by decreasing I. That's kind of what's happening there, okay? Now, if I increase V, make V bigger, but I'm not changing R, then my current goes up. So if I increase voltage, then I also increase current, okay? And if I want to determine the entire, if I want to determine the voltage, let me try this again. If I want to determine the resistance in a series circuit, I am going to add up the resistance of all of the resistors. So all the light bulbs will have a certain resistance, and I will add them all up. If I want to determine the current is the same everywhere. So remember that if I add a toll booth, not only is it slowing down here, but everything behind it is going to slow down. So all of the electrons are going to slow down equally everywhere. So in a series circuit, current is equal everywhere. And if I want to determine the voltage, remember voltage is equal to the resistance times the current. So the voltage will be different in different locations. But if you add up the voltages of each one of the resistors, so if I look at the voltage across each resistor and I add them up, it should be the same as the voltage across the battery. Okay? Now when you get to a parallel circuit, that's a little different because now you're adding a whole new pathway. So now instead of by taking one of these guys out, you're actually speeding up the flow of traffic. So adding a resistor in a parallel circuit is going to make the current go up.